This will be for the con exercise, average rate of change, word problems. All right, so what they mean by average rate of change, that is just the slope. Okay, and if you remember the formula for slope, that is just change in y divided by change in x. Okay, that little triangle is a Greek letter delta. That means change in. So what do we mean by change? We mean the difference. So change in y, you just subtract the y's. y2 minus y1. And then the change in x, that's just x2 minus x1. All right, so when we say the rate of change, we're just referring to the slope. All right, and just a friendly reminder for the y's and the x's, the order that you subtract doesn't matter so long as you go in the same, subtract in the same direction, either left to right or right to left. Okay, so make sure you have y2 with x2 and y1 with x1 for each point. In other words, if you have a point, that point has to be x1, y1, or it has to be x2, y2. Okay, you can't mix up x1 with y2 and vice versa. Iram is sitting on the beach watching the tide go in and out. His distance from the shoreline in meters as a function of time is graphed. What is the average rate of change for his distance from the shoreline increases between the 9th and 13th hour? Okay, so really most of these write-ups you don't have to read. You just have to look at the final sentence or question. Average rate of change between the 9th and 13th hour marks, okay? Between the 9th and 13th hour. So the time is on the y-axis, all right? So the time in hours, and we are going for the 9th and 13th. So 9 would be right here, and 13 would be right there, all right? We want to trace that to the graph. So this is for 9, and this one here is for 13. All right, we're tracing those to the graph. All right, so we're looking to do slope. And that's going to be change in y divided by change in x. All right, change in x we have already. All right, we'll just do 13 minus 9. All right, so for change in x, that's just going to be 13 minus 9. All right, and the 13 was first. So go find the y coordinate for the 13. The graph is right there. If we trace this to the y-axis, the y coordinate is between 10 and 8. That's going to be a 9. So at x equals 13, y equals 9. X equals 13, y equals 9. And the y coordinate for the 9, which is the second number, here's the 9 on the graph. If you trace that to the y-axis, the y coordinate is a 6. So 9 minus 6. 9 minus 6 is 3. 13 minus 9 is 4. That's 3/4. Their answers might be in decimal, so 3/4 is the equivalent of 0.75. All right, so that's it. Does the answer make sense, at least in terms of positive or negative? Well, this is definitely a positive slope, so at least we have that part correct. Answer A, 0.75. P of N models the price in dollars of a pack of N bulbs at a certain store. When does the price of a pack increase faster? All right, so the N values, clearly we're plugging in N into this function P of N. Okay, so usually the input variable is your x. All right, and your output variable is your y. So really, I want to look at the table that way in terms of x and y. All right, and since we're looking for an increase, how fast it increases, we're still looking at a slope. Okay, and that's still going to be change in y divided by change in x. And let's see, n is the number of light bulbs. That's this row right here. So between 4 and 10 light bulbs, all right, we could do our slope between 4 and 10. And let's see. We'll do change in x first. These are the x values between 10 and 4. If we do 10 minus 4 on the x, change in x. And then we're going to do 25 minus 12. That's your change in y. All right, 25 minus 12 is 13. 10 minus 4 is 6. All right, so this will be 13 over 6. All right, let's keep going. Between 10 and 12, let's see what happens there. All right, between 10 and 12, the change in x is going to be 12 minus 10. So that's in the denominator. And the change in y is going to be 28 minus 25. Notice I am subtracting in the same direction in both cases. 28 minus 25 is in the numerator for the change in y. Okay. So 28 minus 25 is a 3. 12 minus 10 is a 2. So we're looking at 3 halves right there. And which one is greater? Well, 13 over 6 is at least 2. All right. If I round, I didn't even use a calculator, but 12 divided by 6 is 2. I'm going to say it's approximately 2.1. 3 halves is going to be 1.5. So where did it increase faster? Well, clearly this one right here increases faster. So that is answer A, okay? They did not do the same rate, so that's not correct for C. Answer A. All right, the temperature as a function of time is graphed. What is the average rate of change at which it decreases between 3:30 and 8:30 p.m.? All right. So, this is the time in hours since noon. So 3:30 is going to be 3.5 hours since noon. Okay, and what was the other time again? It was 8:30. All right, so we're looking at hours since noon. 8:30 is going to be 8.5 hours. All right. So we're on the x-axis here between 3.5 and 8.5 right here. Between 3 and 4, that's 3.5. Between 8 and 9, that's 8.5. So, slope, change in y over change in x. Change in y over change in x. All right. Change in x is the denominator. So that's going to be 8.5 minus 3.5. All right. So that's in the denominator. Right. Change in x is on the bottom. And now we just have to find the y coordinates. We have to go to the graph. At 8.5, if we trace that to the graph, we land right there. What's the y coordinate right there? Well, we trace it to the side. It's between 20 and 16. That's going to be an 18. So the y-coordinate for 8.5 is 18. So at 8.5, we're going to write 18. And the x-coordinate at 3.5, the y-coordinate at 3.5, here's 3.5. We're going to trace that one to the graph. All right, and then when we go, it lands right there, and then when we go to the y-coordinate, that is a 24. So the y-coordinate for 3.5 is 24. All right, so the 8.5, get your y-coordinate. The 3.5, get your y-coordinate. You're in business. 18 minus 24 is negative 6. 8.5 minus 3.5 is 5. All right, and if you do a decimal, negative 6 divided by 5 is going to be negative 1.2. So that is your average rate of change from 330 to 830. Does the negative make sense? Yes, if you start at 330 and go to 830, the graph is clearly decreasing. That's a negative slope. All right, so that's it. All right, 1.2. If you're asking why isn't it negative, because they asked in the question, what's the rate that it decreases? So basically they're asking how much it decreases, and it decreases by 1.2. That's why we got negative 1.2.